Hey guys, so today we're going to start a new lesson called metallic bonding. We've already talked about covalent bonding and ionic bonding, and now we're getting into a new one. All right, so as you can tell just by the name, metallic bonding are bonds that form between atoms of a pure metal. So for example, if you look at a block of aluminum, that's showing metallic bonding, not ionic or covalent or anything like that. So if you can see here, this is an example of a metallic bond. You have all of these positive ions floating in a sea or kept still while the electrons are kind of floating between them in a random area. Electrons are not found in an organized manner. They're totally randomly placed throughout the crystal lattice of a metal. So there's going to be a video that is on your day one section of Shobi. I am going to make you guys go and watch that, and it's already there. All right, so you guys, now, the difference between a metallic bond and any other type of bond is that in this case, electrons are not being shared and they're not being transferred to anyone. They're basically becoming completely free of the atom. And by the electrons, I'm talking about the valence electrons, not the inner electrons. Remember, the valence electrons are the ones found on the outside. So this happens because when you look at the periodic table, all the metals that fall into the transition metal area, which is right in the middle of the periodic table, they have a lot of empty orbitals. So basically they have like 10 d orbitals each, and a lot of these orbitals are empty. Because so many of these orbitals are empty, when the atoms come close to each other, the orbitals basically overlap, and the electron that was originally in this orbital by itself can now move into this atom's orbital, and then this one, and all around wherever it wants to go. All right? So this basically happens. The electrons become completely free to move wherever they want to go because of all the empty spaces in their orbitals. Their orbitals overlap and they get to move freely. All right, so electrons are delocalized, which means that they do not belong to any one atom, but move freely about a metal's network of empty atomic orbitals, which basically means this electron does not belong to this atom, it does not belong to this one, it's completely free to move wherever it wants. That's what the word delocalized means. It means it's not local, it doesn't have a specific place it belongs to, it can just go wherever it wants. It's free. So all of these little delocalized electrons that are just basically swimming around all over the place are known as a sea of electrons, okay? We call it a sea of delocalized electrons, which are moving from place to place. Wherever they want to go, they are not bound to a specific atom, they are free. But just remember that when an atom loses an electron, even though the electron is not completely gone, it can come back and go. This atom becomes positively charged because it has lost an electron. So you see here, all the atoms become positively charged while their electrons become completely free-flowing and delocalized into the sea of electrons. All right, so the chemical bonding that results from the attraction between metal atoms and the surrounding sea of electron is called a metallic bond. So the reason metals stick together and stay with each other is because even though these electrons are free to go wherever they want, they are not free to leave the metal. They still have to stay anywhere where there might be a positively charged ion. So this electron can go here, 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 but it can't go here. It has to stay within this. And because even though they're free to move wherever they want, this attraction between the electrons and the positively charged ions is what keeps the whole metal together. This is what's known as metallic bonding. It's different from any other type of bonding because metallic bonding happens between two metals. You guys remember that ionic bonding happens between a metal and a nonmetal because they have very different electronegativities. And in this one, an electron is stolen from one atom and given to the other. They become opposite charges and they stick together. And a covalent bond usually happens between two nonmetals. all right? So metallic bonds are pure metals, ionic bonds are a mix, and covalent bonds in general are between nonmetals. So you guys, tomorrow we're going to be going over some of the properties of these, but this is a basic rundown of the properties of metals. You guys probably already know them, that they are good conductors of heat and electricity. And I'm sure you can guess why, because electrons are free-moving particles in this particular substance. They can go wherever they want, and as they move, because they're charged particles, they can carry electricity. If charges can't move, we don't get electricity. They are also shiny. They have luster. They're malleable and ductile. If you guys want to know what these are, just go to the next slides. You will figure it out. And they have high melting points. If you guys can remember, when we were talking about ionic bonding, high melting points means very strong attraction between the atoms in the substance. So this is obviously a situation where atoms are held together in a very strong manner. Even though their electrons are free and delocalized, they still hold on to each other very, very tightly. This is why it's very difficult to actually melt a metal. All right, so now guys, you're going to go here to day 1. You're going to start this whole thing by watching this video, and then you're going to do the quiz. All right, so good luck, guys.